Kamu yang terindah, kamu yang melengkapkan hidupku, kamu yang menerangkan.
Hi and Assalamualaikum. Today we are going to explore a classic problem in computer science, the Dunning-Philosopher problem. But first, let's understand what it is. The Dunning-Philosopher problem is a classic synchronization problem. It was introduced by Edgar Dijkstra in 1965 as a way to illustrate the challenge of resource allocation and process synchronization in concurrent computing environment. Now, let's dive into the specific situation of the Dunning-Philosopher problem. Imagine 5 philosophers who spend their time either thinking or eating. In front of each philosopher is a plate of noodles, but to eat the noodles, they need to use 2 chopsticks. Here's the catch. There's only 1 chopstick between each pair of philosophers. As we know, each philosopher can either be thinking or eating. However, to eat, they need to pick up both the chopstick on their left and chopstick on their right. If every philosopher picks up the chopstick on their right at the same time, they will be stuck waiting for the chopstick on their left. This situation will be leading to a deadlock. In computer science, a deadlock is a state where each member of a group is waiting for another member to release a resource, that leading to a standstill. In this case, each philosopher is waiting for a chopstick that is being held by another philosopher, which is their neighbor. So, how to solve this problem? To avoid deadlock, we need to come up with a solution that ensures that no philosopher is left waiting indefinitely. One common approach is to use a protocol where each philosopher must pick up both chopsticks simultaneously, or put down the chopstick if they cannot get both. Another approach is to limit the number of philosophers that can try to eat at the same time. For instance, allowing only 4 out of the 5 philosophers to attempt to pick up chopstick can also prevent deadlock. This ensures that at least one philosopher can always eat, allowing the others to eventually get their turn. This solution highlights important concepts in concurrent programming, resource allocation, synchronization, and avoiding deadlock. Understanding the Dunning-Philosopher problem helps us design better systems that can handle multiple tasks simultaneously without running into resource conflict. Thanks for watching. Stay curious and keep learning.